Alright, hello everyone. So in this video we are going to learn about sequences where the general term is a rational function, a polynomial over a polynomial, as you can see in these examples in the screen. Alright, now we are going to visualize this also. Okay, so here's the sequence. Now if you want to know whether the sequence convergent or divergence, what you have to do is you have to take the limit, right? Now there are a couple of ways you can. Okay, so let me rephrase that. Okay, so let's talk about the limit. So you have to take the limit here. So limit n goes to infinity. You know what, I'm gonna write it. Space is very important to me here, so I have to take the limit here. So let me do that because I'm lazy. Alright, perfect. Now you want to take the limit of this, right? Now if you look at the numerator and denominator separately, in the numerator you have a second degree polynomial of n. When you substitute larger n, when you keep on substitute taking larger and larger n values, what do you think happens to the numerator? Numerator is going to get larger, right? 5 times a square of a larger number plus 2 times a larger number minus 1. That minus 1 doesn't even matter, right? So it's going to infinity. Bottom, denominator, it's also going to get huge, right? So this is, you would think this as infinity over infinity. But that's wrong. This is not defined, okay? So there's something wrong about the thought process. Okay, so we have to take a different approach to find the limit when we run up into this case, these type of cases where you have undefined cases for the limit. If you use that thought process, okay, so it's infinity over infinity, doesn't make sense, it's undefined. So what is the different approach? This is where you have couple of approaches, okay. One approach is to use L'Hopital's rule. Now I will explain that in a separate video. I will explain L'Hopital's rule in a separate video. What is the second approach? Well, second approach, let's discuss about this numerator and denominator again. Now think about this. When n is really huge, in the numerator, who's going to matter? Think about this. Think about n as like the trillion. 5 times trillion square is extremely huge. Plus 2 times trillion minus 1, that minus 1 doesn't matter, right? Think you have trillion amount of dollars, and if you take out, if someone steal $1 from you, doesn't matter. So negative 1 doesn't matter. 2 times n comparably, relatively doesn't matter. Okay, so the most dominating term in the numerator is 5n square. Same argument can be used for the denominator polynomial. 7, 3n doesn't matter because n is so huge, so that 6n square takes over everything. Okay, so 6n square is the dominating term. So n square cancel out, so the limit is 5 over 6. Okay, so that's a one way to think about that. Okay, or we can use an abstract way to do this. Here's the right and correct mathematical way. So what I'm gonna do is I am gonna factor out the highest power in each polynomial in the numerator and denominator. Oops, here there should be n square. So the highest power in the numerator is n square, so I'm gonna factor n square out. So I'm gonna have 5 here when I take out n square. Taking out n square means you are dividing each term in the polynomial by n square, right? 2n over n square, 2n over n square, 1n cancel out, so this is 2 over n, this is minus 1 over n square. I'm going to do the same in the denominator. Look at the highest power in the denominator separately, okay? You don't have to factor n square unless n square is the highest power in the denominator. Highest power in the denominator is n square. Leave the coefficients be inside the parentheses, okay? You do not take coefficients. So 6 you can take, but doesn't matter. So here 3 over n when you take n square, here 7 over n square. Now what happens is n square cancel out. Now think what happens in this sequence when n gets large. 2 over n when n gets large, when denominator gets large, 2 over n is going to go to 0, right? Okay. 1 over n square, it's also going to go to 0, right? 1 over large number, When you keep on taking large numbers, it's going to go to 0. It's getting smaller and smaller. 3 over n, same, it's going to go to 0. 7 over n square, it's going to go to 0. So what happens here is in the numerator, this cancelled out, so that's no longer there. So it's 5 plus 0 plus 0, right? So it's 5. In the new denominator, it's 6 plus 0 plus 0 is 6, so the limit is 5 over 6. In fact, this sequence is convergent to 5 over 6, which is roughly around 0.83, right? Okay, so that's how you take the limit, how you decide the convergence of a sequence when you have a rational function, polynomial over polynomial. Let's visualize this. So I have already input the sequence. So okay, if you don't believe me, look at the first 10 terms of the sequence: 0.35, 0.6, 21, 0.714, 0.75, 0.77. The values of the terms of the sequence are increasing, but the jump between these terms are decreasing. So they are, you can see here 0.80, 0.807, 0.81, 0.811, 0.814. So you can see, look at the plot. The terms of the sequence, values of the sequence are increasing, but they are approaching towards 0.833 sort of a thing, right? So it is convergent. All right. So let's look at an interesting example. So here the thing is, in this particular sequence, in the numerator we had a second degree polynomial, in the denominator we had a second degree polynomial. So the degrees of numerator and denominator are same. Okay. How about this case? Now in the numerator you have a third degree polynomial, in the denominator you have a second degree polynomial. Okay, so let's change it. Okay, what do you think? 5n cube n square. Okay, so let's see what happens now. All right, so now if I look at the first 10 terms of the sequence, so you can see the terms of the sequence are increasing, but it's okay, you can increase. But look at the jumps are also increasing. Let's plot this. Now you can see the terms of the sequence are increasing in a linear manner, in a straight line manner. What happens here? It's a perfect straight line, right? So let's draw 10,000 terms. So this is where the visualization is really cool. Okay, all right, so what I'm gonna do is I'm gonna see they are increasing in a perfect straight line, right? I mean, how come? Right, so it seems to be like this straight line is not approaching towards something, right? Definitely it's going to infinity, right? So let's look at the limit. The limit is infinity. How come? So how does this happen? So let's find out. Now how do we get that straight line? Okay, let's see, let's find the limit. Okay, so let's take the limit. Now how do you find the limit? Again think about this. If you think about the numerator and denominator separately, numerator goes to infinity, denominator goes to infinity, again it's infinity over infinity, undefined, so we have to use that factoring technique. So what I'm going to do is I'm going to factor out the highest power. Okay, so in the numerator the highest power is n cube, so let's take n cube. So we have 5 plus 2n square over n cube is 2 over n minus 1 over n cube. Here let's take out n square, because n square is the highest power. You don't need to take n cube because you took n cube out in the numerator. Okay, you have to take the highest power individually in the denominator. Okay, highest power is n square. That's it. That's what we have. So this is 6 plus 3 over n plus 7 over n square. Alright, now here look what happens. This term goes to 0, this term goes to 0, this term goes to 0, this term goes to 0. Okay, but here n square and n cube cancel out and leave us with an n, right? So what do we get? We will have an n in the top, so it's 5n over 6. Now when n becomes large, 5n over 6 is also getting large. So when n goes to infinity, that goes to infinity. Right, so this is divergent. So this is a divergent sequence. So this is going to infinity. All right, now how come you get a straight line? This is the straight line, 5n over 6. It's a equation of a straight line. Think about this. Y is equal to 5x over 6. Okay, that's what you see on that picture. Okay, so it's the equation of a straight line. All right, let's look at the final example. So the final example is now in the second example we had a higher degree polynomial in the numerator. In the denominator you have a lower degree polynomial. That means the numerator, did I say it wrong? In the numerator we have higher degree, in the denominator we have a lower degree, right? Okay, I hope that that's what I said. So in the numerator you have a larger polynomial. Okay, polynomial is a larger degree, so numerator is increasing rapidly faster than the denominator. That's what happens here. That is why this whole thing represents like 5n over 6. For in 5n over 6, numerator is huge, right? When n is huge, denominator is always 6, so that is why it's going to infinity. Okay, now in this case, in the third example, numerator is first degree polynomial, denominator is a second degree polynomial. So let's visualize what happens. So let me quickly edit. Okay, here n square should be n. Okay, let's see what happens. Alright, so if you visualize the table, so you can see the values are getting smaller, right? 0.36, 0.32, 0.29. So let's look at the plot. Oh, you can see now this looks like 1 over n. Remember in my previous video? So the values are decreasing, right? So let's find the limit using the Mathematica. What do they say? 0. Limit is 0. How come? Again, look at this sequence. If you use the third process, where if you think about the numerator separately, 2n minus 1 goes to infinity, 6n square goes to infinity, so it's infinity over infinity. So we have to use a different trick, right? So what is the trick? We already learned that we factor out the highest degree. So 2n minus 1, the highest power is n to the power 1, so take out a n, so it's 2 minus 1 over n. Here n square is the highest degree, so it's 6 plus 3 over n plus 7 over n square. Now when n goes to infinity, this term goes to 0, this term goes to 0, this term goes to 0, right? So n and n cancel out, 1 n cancel out, so what we get is 2 over, now we have a n left in the denominator, right? Sorry. So 6n, so it's 1 over 3n. Now when n gets large, 1 over 3n goes to 0, right? Denominator gets large, that means the whole term is approaching to 0, right? So it is convergent to 0. Now this sequence is convergent. Okay, now here in this case, what happens in this sequence is, yes, the numerator is increasing, denominator is increasing, but the denominator increase faster than the numerator. But denominator is increasing, denominator getting large means the whole term, okay, is approaching to 0. The thing here is denominator is increasing faster than the numerator, okay? But in the first case, the denominator and the numerator were increasing in the same sort of a speed. The degree was equal, okay? So 3 different cases, good cases. Try to do them with different examples. Use my code to look at different examples, okay? So I'll see you in the next sequence video. Thank you very much. Bye bye.